Good day and welcome to the Math Salon. I'm Dr. Mendem. For those of you new to the Math Salon intends to help students with their class examinations as well as national exams for the GCE and all other examination boards. The most important thing is that we give you tips to handle model questions like the one you see today. So it's important that if you want to stay tuned to our channel, that you subscribe and if possible just click on the bell so you get an alert once a new video is uploaded. So the questions we are going to look today are questions related to logs. They are advanced level questions. There are 4 of them, and these are all model questions from examinations. So the question talks about logarithms. I think before we get into that, I will just give you a recap of some logarithmic properties. The log have as inverse of them exponentials. So if I have, for example, log of a to the base b equal to x, then I would say this would mean the same base raised to the power x should be equal to a. So I can actually move from this to that, and that is really well defined. So if the log of a to the base b is equal to x, that means this base raised to the power x is equal to a. So what is based in the log remains based in the exponentials as well. There's also a property is good to know. If I have a log of a to the base b plus a log of c here, for example, to the base b, then it is log of the product of these two, a multiplied by c to the base b. If I have the log of a to the base b minus the log of c to the base b, then it's the log of their ratio, a divided by c to the base b. These are some of the things that you should keep in mind. There is also the power of the log. So if I have, for example, the log of a to the power n base b, then there's n log of a to the base b. This is something we will learn. And if you have an equation that expects that you solve some logs, then if I have log, for example, of a function to a base b being equal to log of another function to the same base b, then I can actually drop these logs. Effectively, what we actually say is that I can raise both of them to change them as exponentials. For example, I can put b to that power and b to that power, and then f of x will just be equal to g of x. Because this exponent is the opposite, is the inverse of the log. So if you invert it, then you leave the function unchanged. So I take the log, I take the exponential. If you do that, you leave the function just as it was before. But in simple terms, we usually just say, if you are able to express this function this way, you can just drop the logs and the two functions become the same. So I can just say that if I have two functions on both sides, a single function with the same base, then I can just drop these logs and this one will be equal to that. We will also see that shortly. Let's go to our work. There are also some other things you can learn, like change of basis. In these examples, we may not use that, but maybe we'll come to another example where that's applicable. I would show you a little about that. So to simplify this then, it means what we have to do is, notice that we have here, two logs. I forgot to indicate. If this base is 10, then we usually don't write it. It's just standard notation. But you can still put 10 there. So we can actually say there's a base 10 here, there's a base 10 there. But we usually don't write it. Everyone understands that in the mathematics world. So in this case, what we have as a problem here is that we cannot just drop logs here, because on my left hand side I have two logs terms, and on the right I have only one. So I will have to try to combine this here. But the combination that I showed you before for log of a to the base b minus log of c to the base b, there was no coefficient, so it was just a single log. The number here was 1, but here this is 4. So what we do is we try to carry up to the power. I also showed you that. So this will become log of x to the power 4 minus log of y is equal to log of 13. We already saw that when you're subtracting two logs, it's just the log of their ratio. So this is the log of x to the power 4 divided by y, all that to the base 10, and that's equal to log of 13. Because I've successfully made both sides of my equation with single logs with the same basis, I can just equate the arguments. So this is saying x to the power 4 divided by y is equal to 13. Y should be different from 0 for this to be defined. So I can multiply both sides by y, multiply by y, so this y goes off and I'm left with x to the power 4 is equal to 13y. That's the simplification there. We go to the next one. Once again, we have two logs here and no log here. We'll have to define that. Log of 1 to the base b is equal to 0. That doesn't matter what base it is. It could be base 10, could be base 100, could be a million. The log of 1 is 0. So we'll be able to play it here as well. But you can also say, I don't mind. If I succeed to combine this log into a single one, I can move from log to exponential and I get my result. So there's nothing written in the base there, so that means it should be 10. We know that. And this is a plus here, and the coefficients are all 1, so we can apply. That is going to be log of the product. So that's 2 multiplied by 2x to the power 2 plus 2x minus 1. And that is equal to 0. We already have agreed that there's a 10 below here. If that is true, log of a to the base b equal to x means that base raised to the power x should be equal to a. So this base raised to the power 0 should give me this answer. So 10 raised to the power 0 should be equal to 2 into 2 x squared plus 2x minus 1. But a number raised to the power 0, as long as it's not 0, is equal to 1. 0 raised to the power 0 is undefined. But any other number raised to the power 0 is 1. So in that case, we can say this is 1 is equal to, I open this bracket, 2 times 2x squared is 4x squared. 2 times 2x is 4x. 2 times minus 1 is minus 2. If I arrange this properly, I can take this way, or take, whatever you choose. I can subtract 1 here, and then this becomes 0, and I subtract 1, it becomes minus 3. So 4x squared plus 4x minus 3 is equal to 0. We have to solve for x in this quadratic equation. You can choose, either use the general quadratic equation formula, or you try to factorize. I will try to factorize. To do that, I'll look for factors of this. There are many of them, but I should look for the one where when I cross multiply the product, I should get the middle term. So let me say I take 2x here, 2x, and here I split into minus 1 and 3. If I do this, when I cross multiply, this time that is 6x. This time that is minus 2x, and that is equal to 4x, which is equal to this term. So these two and this are factors. That means 2x minus 1 times 2x plus 3 is equal to 0. These factors should give you exactly this. I advise you to always try to check, which means you remultiply them to see if you have this again. It's important to check. So if I have two numbers that multiply themselves to give 0, means either this is 0 or this is 0. So either 2x minus 1 is equal to 0 or 2x plus 3 is equal to 0. Here, I can take minus 1 this way, it becomes plus 1. So 2x is equal to 1 and x is equal to half, or minus 3 that way. So 2x is equal to minus 3, x is equal to minus 3 on 2. But the equation that indicated that x was an element of real positive numbers. So it means it cannot be this. So this is not correct. So my x value is half. You go to the third equation here. Simplify this. Once again, we see that there's a sum here, but I have a problem because the coefficient of this log there is 2, not 1. So first I will take the 2 to the power there. So this is log x to the power 2. It has a base 3 plus log of y to the power 3 equal to 3. So what we try to do first is to make sure that we have a single log on this side. If we do that, then I'm going to have log of, it's a sum here, so it's just the product of this, and they have the same basis. So x to the power 2 multiplied by y to the base 3 is equal to 3. There are two things you can do here. Either we just go to this our form of converting this directly to an exponential, or we try to play around with the logs. I think the easiest one is that. So if log of a function to the base 3 is equal to 3, that means the base raised to the power 3 is the same like this here, x squared y. And 3 to the power 3 is 27, so 27 is equal to x squared y. And that is the simplification. You go to the last one here. There was something that I also would have liked to see based on this, is that log of a number to the same base is equal to 1. That's true, because b raised to the power 1 is equal to b. And if this was 10, log 10 to the base 10 is 1, because 10 raised to the power 1 is 10. So if that's the case, we keep that in mind. There's a base 2 here. I should try as much as possible to get a 2 here as well. So this is half times the log of 8 is 2 raised to the power 3. So this is square root of 2 raised to the power 3 to the base 2. The root of a number is the same like that number raised to the power half. So this is half here, log 2 to the power 3, all that raised to the power half to the base 3. A to the power m, all that to the power n is a to the mn. So I multiply these two. 3 times half is 3 on 2. So this is half log of 2 to the power 3 on 2 to the base 2. Excuse me, sorry, yeah, base 2. Once again, we saw that the powers could move. So we took this there, we can also bring it back. So I can take this power and bring it in front. If I do that, then I have half times 3 on 2 log 2 to the base 2. Well, log 2 to the base 2 is 1. And half times 3 on 2 is 1 times 3 is 3. 2 times 2 is 4. And that is 3/4. Because this is 1. I just indicated that here. Thanks. And the next videos will be talking about exponential and how to solve the equations relating to that. Hope you liked it. If you did, please give us some thumbs up. Remember to subscribe, share with your friends, and I would advise that you watch in groups. This way you can learn from each other or discuss. Have a great day. Bye.